Hello, this is Caleb Solvay from Table Aerospace, and this is a tutorial on the rocket building and simulation program OpenRocket. And to start, we are going to use a nose cone. This program is completely free. We're just going to click on nose cone. I'm going to get rid of this menu. We don't need that right now. That is how you use parts that you can buy. And we are just going to select our material from this menu here. We're going to pick fiberglass and regular paint. And there are many settings you can use for this. One is conical, the other is ogive, which are on before. The other is ellipsoid, power series, parabolic rather, which is basically the same as ogive. And I think this is pronounced Hayek. We're going to stick to ogive for now. And to start, we're going to build a 18mm rocket. So we want a wall thickness for this. So we're going to do 19mm. That way we have a little bit of space. And for the length, we're going to do, let's say 75. And we're going to add a shoulder in this tab here. I'm just going to play around with this a little bit. I'm going to go to about, let's say 1.5. The diameter of 1.7. And we'll fit inside our tube. Or maybe 1.75. Good. Once we do that, we can hit OK. And now we have a nose cone. Or end capped. Make sure that that's on. And select body tube. Once again, close this menu. And we're going to set this one up. This looks about right. Going to pick craft phenolic, which is like a laminated paper type substance. And outer diameter 1.9. Inner diameter of, since this is an 18mm rocket, 1.8. Alright, that's done. This is all set up. And we can hit OK. Now we're going to start with fins. That's the next step. We select trapezoidal. And I normally go with 4. 4 is normally a good number for these. And this is a very, very, very large fin. So make that smaller. Actually, that looks pretty good. And maybe go like that. And then you have a fin. Not quite done. You can choose to have it square, rounded, or airfoil. I normally choose airfoil. And with a thickness of, let's say, inches, do an 1/8 inch. And component material, I would normally work with balsa. Balsa is a good material for that. And for fillets, I'm going to use a custom one. You can make a custom one by setting a name and a density. I'm going to use my custom one, which was epoxy resin. Fillet radius of 0.25. I'll just give it a little bit of aerodynamic stability there. And if you don't like just doing trapezoidal fins, there are several other options, and you can convert these to freeform. I'll show you how to do that. And now it's a freeform. So if we go into shape, now you can modify the shape in real time. We can make this curved if we want to. Like that. Add another one there. And then you have another fin. You can add fin tabs to make it through the wall, but we're not going to do that in this tutorial. And you see, now that we have fins, we have a very, very stable rocket. It's also due to the fact that we don't have an engine or a parachute, which we can fix now. So we're going to use is an 18 millimeter. So we actually need to go back to the spotty tube, select motor, and hit this component is a motor. Hit OK. Motor mount rather. Now that's selected, hit new configuration. I already have SD selected as a manufacturer. And we're just going to select any 18 millimeter motor that we find in here. Those should fit. I'm going to go for a little bit higher power. I'm going to go for a C6, which is fairly high power, and hit OK. See, now our motor's in there. And now, if we go back to rocket design, we can add just a ring. Close that menu once again. And we are going to move it, I believe. That would be 7. The wrong direction, sorry. -7. And we're going to make this, once again, out of balsa wood. The thickness of 1/8 inch, which is, once again, 0.125 inches. The inner diameter of, since it's an 18 millimeter motor, we're going to do 16 inches. That was, millimeters. 16. I always make a mistake for some reason. And for this, we're going to do just 18. Now, we have that. So now, as you see, we're less stable, but we actually have a motor. If we go to flight simulations, there's a little warning there. We don't have a recovery device. So, when we do this, you see, we hit the ground at 51 meters per second, which if I open a calculator, that would be almost 115 miles per hour, which is not very good for this. And so we need to change that. We have a really high apogee rather, and an incredibly fast speed. So what we're going to do is we're going to add a new parachute. Once again, close menu. And we're going to use Mylar. We're going to make it a 1-foot parachute. And we are going to make this thread out of nylon flat webbing. Now, this is not quite right here with that, so we're just gonna move that there. I'm going to make that a little smaller. That fits. A little bit longer. Just a little bit of a shift. And then hit OK. And then we need to add a shock cord, which, same as before, we're going to use nylon webbing. And then hit OK. This, we're going to shift backwards behind that. Make it a little bit longer, thinner. It actually kind of looks like a cord. I'm not sure how I would pack this. I haven't dealt with that stuff yet. And then hit OK. Then this is a bit more stable. And we have a recovery device. Now, if we simulate it, just going to delete this. And hit new. And you see, it'll have coordinates that are somewhere in the southeast United States. So, and then altitude of 0 meters off the ground, off of the water rather. So let's change that to 120 feet. And we're just going to use the standard for everything else. And hit close. When we run it, it says that recovery device deployment at high speed, 116 meters per second, which is a bit extreme, which means the rate of delay is wrong. So if we see where it is, take off that and that. Yep, this looks good. We deploy before we're done. And then we close down, which means that would shred our parachute, which we do not want. So we close that. Go to motors and configuration. See, this is a C60. That's, we need is like a C6, something more than that. It's a little low. Let's say 3. C6 3. Now if I go there, once again, it's bad, but not as bad. So if we plot, notice that still we're not applying an applique. So in that case, you can go back, select, and let's move on to 7. At that point, we have a little check. We have really high apogee, and a pretty long flight time, and a minimal ground hit velocity. So if we plot that, that was the magic number. We deployed just about at apogee. Close. And now you have a fully built rocket. Well, may your skies be blue, and your winds be low.